From Squallywood, it's the Dan and Ron Show!
Pressure or force? Either way, we'll tell you where to put it. I'm Dan.
And I am Ron.
We are the Dan and Ron Show.
Pressure, one of the three skills. We regulate it, we direct it, we control it. But what does it do for us? There must be more. Let's see what pressure really is.
Pressure is force over unit area.
So let's look at force first.
A force is a push or a pull upon an object, resulting from the object's interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the objects. Not that kind of force, this kind. When the interaction ceases, the two objects no longer experience a force. For some fish, forces only exist as a result of an interaction.
So the ski's interaction against the snow is a force, but it is usually referred to as pressure. How is pressure different than force?
Pressure, I told you, is force over unit area.
So pressure is like a force. Its interaction is over a certain amount of real estate.
Yeah, if I was wearing a running shoe and I step on your foot, it would only hurt a little. But if I step on your foot while wearing this pump, that would hurt a lot. That's pressure.
So pressure is the embarrassment of wearing pumps. To increase pressure, we put the force over a smaller area. Maybe this is why there is no force on the front part of the ski when we move our body forward. But we can increase pressure when we tip the ski up.
That is why we make the mental jump from force to pressure. To change from force to pressure, you gotta tip the ski up. Same force, less surface area makes pressure. Can't make an arc and carve turn with a flat ski.
At least without a rut or some snow to create that interaction.
You can make pressure by standing on one ski and or moving the center of mass forward and outward. But the pressure that turns the ski is the interaction with the snow. Thank you, Professor.
This is why the coaching advice of pushing on the ski is an insignificant way to increase pressure in the turn.
To increase pressure on the ski during a turn, the ski has to be tipped up. The width of the tip and the tail engage with the snow, while the narrow middle flexes until it contacts the snow. This flex ski is the bro's secret to arcing it.
We could group pressure into two silos. One that entails our colloquial use of the word pressure, but actually deals with just force. Actions like moving foot to foot, flexion extension of the lower body, and fore-aft movement. Then another silo that deals with actual defined pressure, like tipping the ski or edging. This is why the expression edge pressure keeps hanging around.
So, what is that pressure that results from edging dependent on?
In the turn, force is dependent on mass, velocity, and turn radius. Mass doesn't change, unless you have a very fast-acting diet. Velocity is very important because it is a squared component. And when the turn radius gets tighter, the force also increases.
We have all seen the Z-shaped turns of the learner where everything is done after the fall line. They skid sideways. They haven't yet learned to control their speed through turn shape, so they go from one turn to the next herky-jerky, which ends up being a skid at the end. Part of the reason they skid is they have essentially reduced their turn radius, which increases force and therefore pressure, which they can't control. The goal of the skier is to create a round turn. That way, pressure is distributed throughout the entire turn and not just at the end.
This round turn with pressure throughout is the goal of all U12 skiers.
And the goal of most recreational skiers. The pressure distributed through the entire turn is easier because the pressure does not happen all at once.
As the U12 matures, the pressure phase decreases. Notice that as the length or duration of the pressure phase has decreased, there is one common element. Pressure is always in the fall line. This ball might help visualize pressure location. The ball ricochets off one lateral rail toward the next rail. The ball bounce imitates the turn pressure, and the rail represents the fall line. If we move the rail from being in the fall line to after the fall line, the ball, or skier, will rebound back up the hill.
While the recreational skier and the big mountain skier will use pressure after the fall line for speed control, the racer with late pressure trying to hold edge angles explodes back up the hill.
Yep, for the racer, pressure after the fall line is for emergency use only. If the racer lessens their edge angle, they lose pressure and their line. They end up sliding sideways and sideways, sometimes with not the desired result.
No matter the length of pressure, we say balance against the outside ski as opposed to stand on the outside ski. When the skier has control of their balance, they can control the duration and location of pressure.
Many skiers attempt to achieve edge angle too early, and often with angulation. This hinders their max edge angle. A good rule of thumb is to make inclination, then angulation. Are you making edge, then pressure, or pressure, then edge?
Moving the body or center of mass from the inside of one turn to the next allows the skier the option of going straight to an edge ski or redirecting from a flat ski and then to an edge ski. For the MA fanatics, watch what the skier does at the moment of transition, when the skis are flat.
Redirect or stivot is a common ski racing strategy when the ski's physical dimensions will not allow the arc-to-arc turn or when the ski racer wants to reduce line. If the ski racer creates pressure too early, the result may be a hook tip, a double turn, or just lack of pressure at the bottom of the turn, which results in a skid that does not direct the skier to the next turn.
Pressure throughout the entire arc of the turn is ideal for 99% of the recreational skiers. But for those that want to drag knucks, they may get pressure from those watching from the chair, but what they need is a tipped up ski, reducing radius, and good snow.
To make a turn takes a certain amount of pressure. That's interaction. If that pressure is put in a shorter amount of time, the impulse of that pressure is larger. As the ski racer matures, they're able to postpone the application of pressure, resulting in a shortened pressure phase. What makes this turn faster is the reduced distance the ski racer travels, which is a result of the shorter radius coming from the higher pressure of the tipped up ski.
This is faster and very difficult. Just like everything we teach, it must be progressive. Trying to ski like the World Cup athlete comes in small steps. Make sure you are coaching to the skill level of your audience and not having them bite off more than they can chew.
With that great advice, let's summarize.
Force is a part of pressure.
But pressure is not a part of force.
Moving forward on a ski does not necessarily increase force or pressure.
Pushing on the ski does little for turn pressure.
Tipping a ski up creates pressure.
The force or pressure of a turn is dependent on speed and radius.
Arc-to-arc turns need to be mastered.
Elite ski racers advance to shortening the pressure phase,
which decreases the radius.
and don't forget, pressure in the fall line.
Okay, thanks for joining us. We'll see you next time on the
Dan and Ron Show. Did you really not have your pants on?